Good afternoon, everyone. My name is Ronald Wei, Category Manager at OECM, a trusted not-for-profit sourcing partner for Ontario's education sector and other broader public sector entities. We currently have over 85 agreements available to more than 1,400 organizations. This is our very first co-hosted webinar with AEL Environment, one of our supply partners offering outdoor environmental professional services. Welcome and thank you for joining us for today's webinar on innovations in environmental site remediation. And with that, I'll pass the floor to AEL for the presentation.
Perfect. Thank you so much, Ronald. We really appreciate OECM for inviting us and for hosting us. And we're very excited to share this time with everyone and the subject that we're passionate about. We also want to be respectful of your time, so we're going to aim to focus on what's most important and most relevant and welcome you to follow up with us at any time if you'd like to deep digger. And we have provided our contact information at the end. So during the Q&A, there will be a Q&A at the end. We're planning to leave 10 to 15 minutes for Q&A. And if we don't get to your questions, feel welcome to contact us and we're happy to start a discussion with you. You'll note that on the top of your interface, there is a Q&A button. That would be the best place to put your questions, but we'll keep an eye on the chat as well. But again, planning to hold those to the end. So feel free to add your questions at any time, and then we will open up the floor when we get to the end of the presentation. So I would like to introduce my colleagues, Charna and Gavin, who are with us here today to present. And oops, just get this going. I've got their pictures up, although I'm sure you can see them live. There we go. Charna and Gavin. So Charna is a senior engineering professional who has been in the practice for over 30 years. She's extremely knowledgeable and helpful with our clients to help them manage environmental risk. In addition to being a professional engineer, Charna is a qualified person for environmental site assessments at QPESA, as defined by the MECP. And Gavin's a professional geoscientist and remediation specialist. He's got over a decade of experience leading complex remedial projects. So AEL, my mission with AEL is to make sure that the world knows about us and our services and to connect our team to our potential clients. So AEL is, we provide services nationwide. Our focus is on providing practical solutions for managing environmental risk for our clients. We support commercial real estate transactions, but also public sector entities, developers, municipalities, private businesses, even residentials. And topics for today's discussion, I will pass that over to Charna from here.
Thanks, Angie. I apologize for my voice to begin with, but hopefully you'll get the mainstay through my croaking here. So today we're going to go over basically the evolution of environmental regulations, high resolution site characterization, enhanced contaminant consideration, traditional versus modern remediation techniques, advancements in in-situ remediation technologies, some innovations in remedial amendments. If we have time, we'll talk a little bit about the integration of GIS systems and then the role of risk assessments in remediation usually towards getting records of site conditions for sites. So those will be the sort of the main topics we're hoping to hit today, given enough time. So for many years, and some of you have been doing this, if you've been doing this, over the past decades or more, you'll remember that environmental contamination was just overlooked. It wasn't talked about historically. It was the out of sight, out of mind idea. It was if you could dump it in a back and cover it with some soil, it didn't exist. So the Ministry of the Environment, in terms of protecting both human health and the environment, by Reg 0153/04, it was introduced in 2004, and then the actual site standards were updated in 2011. So this OREG 153/04, which basically guides the environmental sector in our evaluations. It gives you the proper procedures for environmental assessments. It gives up clean up contaminants of sites. It gives you the expectations of what and how you need to report on for records of site condition. And it integrates the ability that the site doesn't have to be what we call completely clean. It gives us the ability to work with risk assessments to be protected for the environmental site and liability going forward. So now I'll pass it on to Gavin, who will go a little more in depth in these topics today. Thanks, Gavin.
No problem. Thank you, Charna. So we'll talk first a little bit about site characterization and how it's changed over the last few years. So site characterization has come a long way since environmental work first started being done. And we're going to kind of focus on high-resolution site characterization in particular, which is a relatively new, powerful tool that increases the speed and efficiency of phase 2 investigations and provides valuable information to support remediation design. And the way it does this is by allowing for significantly more data to be gathered during an environmental investigation as compared to traditional investigation methods. And the net result of this is that it allows for enhanced decision-making when it comes to testing, treating, and mitigating environmental contaminants. So our next topic is a more specific example of high-resolution site characterization, and that is the use of a membrane interface probe. So a membrane interface probe is a combination of sensors and sample collection devices that can be attached to the end of a drill rig and hammered down into the subsurface. And as the drill rig hammers the membrane interface probe down through the soil, it continuously collects soil vapor and analyzes it for contaminants that might be present in the soil. This results in detailed logs of contaminant profiles with depth into the subsurface, and these logs can then be put into models to create a much more accurate and specific visualization of the underground contamination. So if you look on the screen on the right there, you can see that's me holding one of these membrane interface probes, and then beside that is the sort of readout that you get. And that graph on the side with all the little lines of different colors, that's just basically logging essentially the amount of contamination as we're progressing that kind of probe down through the soil. So then these the models that we use or that are generated by this kind of information can then be used to support a much more targeted remediation approach. And this can both reduce remediation costs and provide higher certainty of complete remediation. So if you were to compare high-resolution site characterization techniques such as the membrane interface probe to a more traditional approach where only a handful of soil boreholes are advanced and only, say, 1 or 2 discrete depth intervals are sampled from each of these boreholes, you're going to realize that you receive substantially less information and leave significant gaps in knowledge about the location of contamination. And you risk then either missing some of the contamination when you go to remediate, or you risk over-designing the remediation program and spending way more money than needed in order to buy the certainty of remedial success. And the MIP, or the membrane interface probe, is just one example of many high-resolution site characterization technologies utilized by AEL. And selecting and applying the correct technologies at the correct time is important, as high-resolution site characterization techniques vary and not all may be applicable to your contaminated site. So high-resolution site characterization techniques should be used strategically in specific scenarios to reduce budget and increase confidence in your desired project outcome. Let's move on now to discuss typical contaminant types that may require remedial intervention and kind of go through the history of that. So historically, the primary focus for contamination was petroleum hydrocarbons, or PHCs. This relatively quickly expanded to include a broad range of contaminants, including metals, polychlorinated biphenyls, or PCBs, polycyclic aromatic hydrocarbons, or PAHs, volatile organic compounds, or VOCs. They have pesticides, phenols, explosive ordnance compounds, radioactive compounds, and much, much more. And not only that, but as industry progresses in general and new compounds are created to support that innovation, this also results in additional new contaminants being formed, or what we consultants like to call emerging contaminants, which are kind of always on the horizon. And as an example of this, currently, environmental decision makers are grappling with regulation around PFAS and microplastics, which are 2 emerging contaminant classes which could potentially be adopted as regulated contaminants of concern within Canada, or Ontario over the next decade or so. However, innovations in industry also means innovation and progress in laboratory equipment, which allows us to detect contamination at increasingly lower levels. And that's reflected as well in the regulatory standards. So where allowable contaminant concentrations were once in the parts per thousand, we can now analyze and understand health impacts of contamination at much lower concentrations. And as a direct result of this, the current allowable levels of contamination at a site typically range between parts per million to parts per billion, and in some cases, even parts per trillion. And so these are obviously much more protective of human health, but it also impacts the cleanup criteria where it's a much more higher bar that you have to reach for cleanup than it used to be. And so the last point here is because we have this increased capacity for testing, as well as other technological advancements, knowledge of contaminant migration mechanisms has also increased substantially over the last couple decades. And this allows us to design and apply remediation techniques more efficiently and effectively than before. I'll pass it off to you now, Charna, to talk about the traditional remediation techniques. You're muted. Still muted.
It's good. My voice sounds so much better when I'm muted. Thanks. So when we've got these new methods that have evolved because of the way things used to be done. So traditional remediation was dig and dump. On site and in situ and other things were very expensive. So you did a dig and dump for soil. You might do a pump and treat then for water. So, dig and dump, just like it sounds, you're excavating the contaminated soil, just moving it to a landfill, and it's just there. So, in the past, this was problematic because the landfills weren't really designed to hold some of the things we're putting them in now. And so you end up with seepage out of the landfills as well. And you're basically just moving your problem from one area to the other. And as landfills filled up, we have a limited amount of area to work with. Pump and treat, just the way it sounds. You'd have a network of wells, and you'd put them in the area of your groundwater plume, or what you thought was your plume, and you'd pump it out and treat it on site, and then release it back into the environment. So this was widely used, and it's still used in some scenarios where you need some rapid control of the groundwater contamination. However, long-term, pump and treat has been shown in a lot of cases to be really ineffective. And it's an ineffective practice in a lot of cases because it takes the immediate contaminants you see in that groundwater. However, it doesn't address the contaminated soils, which can be acting as the source for the groundwater contamination, and you end up with back diffusion. So you think you've treated it, it's back diffused out of the soils, and the end result's that the groundwater is only remaining clean while you have that active system on the site, and nobody wants to pay for that long term. So when you try and look at a site and going beyond a 5-year mark and longer, it doesn't become practical for site ownership or for site cleanup because of this back diffusion. So both dig and dump and the pump and treat should be avoided where possible. There are better solutions nowadays, better solutions in terms of cost, timeline, energy expenditure, and your final outcome. So it is a history. It has its place, but ideally nowadays that is not something we recommend for most of our sites. So what do we recommend? Well, I'll let Gavin talk about that a little more. Thanks, Gavin.
Awesome. Thanks, Charna. So the next logical question then is, what can we do instead of removing contamination through excavation of soil or pumping of groundwater? And it turns out there's actually quite a few options. Over the last few decades, several large classes of technologies, they've been developed and also continuously improved. Some common ones that you might have heard of include in situ chemical oxidation, in situ chemical reduction, thermal remediation, and bioremediation. These approaches rely on physical, chemical, and biological properties to either immobilize, destroy, and render contamination inert. And they can be applied either in situ or ex situ, which means they can be either introduced directly into the contaminated subsurface, or the contamination could be excavated out and treated above ground before being placed back as treated soil. In AEL's experience, in situ chemical oxidation, reduction, and thermal remediation all benefit greatly when they're combined with bioremediation practices. And this is because the non-biological portion of the remediation process tends to quickly remove most of the contaminant mass. So a well-designed remedial program will typically get 90% plus of the mass of contaminants out of the groundwater and or soil. And the remaining contaminant mass, which is the last 10%, can then be treated by the longer acting biological portion of the remediation process. So the last 10% of treatment is important, as it's that last bit of contamination which is treated by the bioremediation process, which is typically the portion of contaminants that back diffuse, creating those long-term costly groundwater impacts. So AEL typically recommends a hybrid approach where there's a quick reduction in contaminants through a chemical or thermal treatment, and then that's followed by a longer acting biotreatment which controls back diffusion. And that's ultimately going to lead to site closure, enabling development or redevelopment of the property. As previously mentioned, there have been ongoing innovations in chemistry and biology of the compounds used for remediation. So remediation amendments have generally become more reactive, longer lasting, and they're often created as mixtures of compatible and synergistic compounds. An example of a new innovation, a relatively new innovation in remedial amendments, is an injectable version of activated carbon, of which now there are several different varieties. Carbon-based injectables are effective because they essentially turn the subsurface into a giant carbon filter that can remove most groundwater contaminants relatively reliably. This technology is often combined with bioremediation or another complementary technology to not just filter the contamination out of the groundwater, but also to destroy it. And bioremediation in general has become considerably more effective over the years. So in the past, practitioners would rely on typically naturally occurring microorganisms, and they try and enhance their numbers through a variety of different methods. And this approach is still valid and it's still used today. But now you can also use a specific advanced microbial mixture, which can be engineered for a very specific treatment of a wide range of different contaminant classes. And that's a pretty big deal, since well-designed bioremediation, as we've mentioned before, is a very powerful tool to prevent the dreaded back diffusion, which plagues so many remediation projects. And I'll pass it back to Charna to talk about GIS systems.
Thanks, Gavin. So GIS is used in the environmental field, in another engineering and planning fields for a variety of things. So the GIS, the computerized software, it's designed to help us interpret the data within hours. So we get that data, it's integrated, the speed, the accuracy, the quality of the results, they make it an invaluable tool. The information is displayed in many formats. You can have high-res maps, you can have charts, you can have reports. So the idea is to be able to take your GIS data, take the data you've had, put it in a format that ties it both spatially to the site and allows good visual representation. We can have lots of information as scientists. If our clients don't understand it, or the people that we're trying to explain how it has progressed can't understand it, it doesn't make any sense. So a great big table that comes out of a lab that's got 42 rows times 28 rows, that's not easily understandable. The GIS systems and the way we tie this in allows us as professionals to communicate the data both in real time, because it's brought in and can be put out really quickly, and it makes it easier to move forward with an appropriate plan for the site. When you can visually see, it's a little less of the brain power and becomes a little more intuitive as to what you're going to do with that site to make it work. So the GIS systems that we use and the integration to our data point acquisition and our ODK forms that are in real time able to be downloaded have become an invaluable part of the remedial systems and how we design them nowadays. So Gavin talked a little bit about the cleanup. So the ideal standards, the MECP standards for a site, they are a generic standard. So as we explained to our clients many times, even when we're comparing it to a set table of standards, those standards are a risk assessment. So what's the role of a risk assessment in remediation? So those generic standards are based on a set number of information and generalities for a site. So risk assessment helps us to understand the actual risks associated with a specific site condition. So the information, it's then able to inform the design of the remedial plan to mitigate the risk versus the cleanup of the site. There is no use changing what the site actually in the form that it's in or the impacts if they don't actually pose a risk. We look at pathways for risk, pathways for migration, and then what those end risks are. So the risk assessment for the site specific takes the same calculations that are done with the MECP generic and applies them to the site. We encourage our clients to integrate as much as possible for highly impacted sites, a combination of remediation with risk assessment. It reduces the cost and the unnecessary cleanup that might be done to the site. If you don't need to, quote, polish the site to that last 5%, because when you calculate the risk, it really is not a risk for your specific situation, then there is no use spending time, effort, and money to do that for our clients or for the environment. So the role of risk assessment has become much more understood and a much more valuable tool within remediation. And it helps us create that targeted strategy and focuses us on the significant risks to the site, not just the sideways slight risks, but the actual risks that need to be mitigated. So we encourage our clients not to be afraid of risk assessment, to understand that all of those generic standards themselves are a risk assessment, and to be open to that fact of using a risk assessment along with the general remediation plan that comes about. So Gavin, if you wouldn't mind going over some of the particulars, that would be appreciated.
Yes, absolutely. So you may be thinking to yourself, okay, so I have a contaminated property that needs, remediation, or maybe a risk assessment, or maybe both. But how do I make an educated decision how to proceed? Because the last thing you want to do is, spend a ton of money on a remediation job or risk assessment job, and ultimately it fails, which unfortunately it does happen more often than you might think, and it's typically caused between poor communication between the property owner and the remedial practitioner, and that goes both ways. So to ensure everybody's on the same page and that all remedial options have been evaluated correctly and that the optimal path forward is selected, in AEL's opinion, and in my opinion, it's wise to begin remediation projects, especially for complex contaminated sites, with a remedial action plan. So remedial action plans are designed to assess and rank all of the potential remedial technologies that are applicable to your specific contaminated property. They consider the efficacy of the remedial technologies, and they also integrate the client's input and considerations into the decision-making equation. So the client gets input into all the different factors that are considered in the remedial action plan, and that can be things such as, desired timeline, the budget, the allowable degree of interference with daily site operations, specific health and safety considerations and requests, and anything else you can kind of think of. That can all be included into the final equation for determining the best remedial approach. So a good remedial action plan should include a synopsis of the site and its contamination issues, the client's goals, a transparent review and ranking of all the available remediation technologies, as well as all the factors and the weightings of the factors that go into that ranking, and a pros and cons description of the top, let's say, 3 to 5 remedial technologies that are selected. And then the remedial action plan should then recommend one or maybe more options from this 3 to 5 shortlist that could be successfully and are most likely to be successful when employed at the site. And that doesn't just have to include only remedial solutions. It can also include risk assessment and different types of risk assessment. So what AEL does after this, that report gets delivered to the client, and we always come back and review the remedial action plan to make sure we're all, completely on the same page. And if there's any questions or concerns, we can discuss those at that time. So key takeaways from this presentation. Innovation in remedial technologies and techniques has been driven by the need for environmental stewardship and increased environmental stewardship among landowners, property managers, and developers. Because of this, more stringent standards have been legislated to reinforce sustainably focused practices and to protect human health and the environment. Legislated requirements represent minimal acceptable compliance, but if you would like to set a higher bar, there's still more that we could do. It's very important to partner with experienced remedial practitioner or environmental consultant who will integrate modern approaches and techniques in the form of like a remedial action plan, for example, to protect your assets and achieve your final site goals. I'll hand it back to Angie. You're still muted, Angie.
Thanks so much, Gavin and Charna. I'm going to just do a very quick breeze over our capabilities outside of remediation since we've got you here, and then we'll move on to the questions. So I'm not going to read through the whole list, but we focused on remediation. We do offer a number of additional services that clients need, often precursors to remediation, such as environmental site assessments, building condition assessments, aerial surveys, peer reviews, and more. And if you don't see something here on this list, it's always worth asking because we probably do it or can help you find someone who does do it. So we're happy to present also on any of these subject matter areas of expertise. So if you have questions or if you'd like us to work with your group, feel welcome to reach out and you'll find our contact information on the coming slides. Again, just breezing over this, but our clients are typically looking for qualified professionals. So we've just included a list here of the professional designations and insurance needs that a lot of our clients are seeking. And just to note that our reports are accepted by all the major banks, organizations such as the OECM and its clients, and that the majority of our business comes from referrals. So whether it's developers, lending institutions, or other satisfied clients. So thank you so much for sticking with us to the end. We've actually got a bit more time than we had anticipated for questions. So we are going to open it up. And again, if we don't get to your questions, we welcome you to give us a call. These are Gavin and Charna's direct numbers and email addresses, and we're absolutely happy to answer any specific questions that you have.
We do have one question in the Q&A box from Shakil.
Yeah, I'll read that question. So the question was about the Ontario Reg 406/19. So for those that aren't familiar, the Ontario Reg 406/19 mandates it's the clean fill reg. And so in addition to the testing regs for chemical analysis, Ontario has come up with a way to manage and to try and minimize the amount of soil that is being moved directly to landfills that can be then hopefully reused on other sites where it's applicable. So the Reg 406, as Shakil's noted, it's got a sliding scale. So the sampling frequency 0 to 350, 350 to 600, blah, blah, 10,000 to 4,000 cubic meters. So how many samples per cubic meter of soil? So how does the MIP relate to this? So if you're using MIP, you would then be able to integrate the number of samples that you're getting. We have not to date done a clean fill application with a MIP device. So that is something that I would absolutely consult with our MEC partners before we did it. But it would give you the ability to then, for a smaller discrete area, get a lot more samples with the MIP. Like Gavin explained, your traditional soil sampling through a borehole log. For each borehole, you typically are only getting 1 to 2 samples. With the MIP, when you go down that hole, you're acquiring many discrete samples. So although there is a number, say for the 350 to 600, you're going to get 3 samples plus a leachate plus an extra sample for every additional amount. You absolutely, because this is a new reg and MIP is not typically used for soil disposal, it will be something that Shakil would reach out to the MECP to see, because the number of MIP samples going straight down a borehole is, you may end up with 20 readings down that hole. And that's 20 samples, but it's 20 samples in a discrete location. So the 20 samples in a discrete location isn't really indicative across a whole site necessarily. So that is something that if you were going to have to use the Ontario Soil Registry, the RIPRA registry, the soil registry, because the soil was really not looking at the 350, but more say the 10,000 plus cubic meters, that's something we would consult with the MECP to say, hey, if we want to use this and we want to reuse this, what's your guidance on how many MIP samples relative to the site would be acceptable? That isn't something that we've done to date, but that's a very good question, and something that maybe I'll take some time out this week to phone the MECP and get a little feedback on that. So yeah, thanks for asking that. We had another question about long-term tenant responsibility. So the question was about long-term tenant responsibility when leaving a site. So we deal with a lot of clients, and more so nowadays, that are tenants to the site, because your responsibility, and full disclaimer, not a lawyer. Engineer, not a lawyer. So I'll give my 2 cents worth as a engineer, the not a lawyer person here. Legal responsibilities are set out in a lease. So the tenant really needs to go back to their lease to see what responsibilities they've taken on. They also then becomes a ministry mandated thing. So beyond your lease, if you've been a tenant on a site and you've impacted a site and you leave it, it would be up to the person that you had impacted as to how they come back for compensation. That is something that absolutely needs to be consulted with an environmental lawyer. We encourage all of our clients, and we definitely have found, I've been doing this for 30 years, so I would say in the last 10 years, there has been a large increase in the number of tenant-based investigations where they get baseline investigations. So we always encourage our clients that are going to a site where there may be a high chemical usage that may have occurred before them or may occur after them to get these baseline studies done. So the best way to proactively take care of yourself is to have these both pre-occupancy studies done and post-occupancies before you leave. If you don't get a pre and a post, then it becomes a he said, she said game of liability. And you're definitely open to being responsible for that, because it's not only the site owner. There is, again, not a lawyer, but have seen enough webinars. There's absolutely legal precedent that it is not only the owner but tenants that are held responsible for site impacts. So that's the best thing you can do to proactively take care of yourself, is have a pre and post investigation done for sure.
Ronald, I'm not sure if you've received any other questions or if we're going to wrap up with this. I do have a AEL 25th anniversary prize giveaway at the end as well.
Oh, actually, I do have a follow-up question for Charna and Gavin. So, I heard about like one of those slideshow, like you work with some banking institutions, but I'm not sure if there are like any government incentives for our customers to clean up their contaminated sites.
Yes, and that varies, Ronald, from municipality to municipality. So there are brownfield grants. And so your best connection to that is your planner. So when you are getting ready to redevelop a site, we can check for you, and we have checked with clients before. I know we've worked a lot of the Hamilton area. Hamilton has a lot of brownfield sites, and they do have grant programs. And it, again, is one of those things as part of your planning process you want to do in advance. The paperwork is not any more untoward beyond the phase 1 and phase 2 and remedial reports that we normally prepare. But there is paperwork that needs to be submitted. So we always do encourage our clients to reach out. The people who reach out to is your municipality. And many of the larger ones, and some of the smaller ones, do have what's called brownfields grants for redevelopment. Municipalities have had to do this because they've been stuck with non-tax generating large portions of land, and without these grants, they just weren't getting the response that they needed. There are the cases where they have the guidelines they have, in the reasons that the banks are so cautious is because when clients do walk away due to financial considerations, due to impacts or remediation needs, there has to be a way to recoup that cost. And so the government has been involved in a lot of these. So again, best person to go to with that is your planner, and have your planner reach out to the municipality to discover if there is a brownfield grant for your particular area. But a lot of them do have. Yeah, that's a great question, Ron.
Thank you.
All right. If we don't have any more questions coming in, then I will welcome anyone to reach out directly to either Charna or Gavin at the information listed on the screen, or just go to our website, aelenv.com. And thank you so much for attending the webinar today. I will let you know that we do have a 25th anniversary giveaway that we'll send out an email just after this webinar to everyone who took the time to attend. And we will send you a form that you can just fill out and let us know where to send your gift. So thank you again, everyone who took the time out of their day, and we welcome you to reach out to us at any time. So thank you, Ronald and OECM.
Thank you, Angie. Thank you, Shanna and Gavin. We do have, we have Adam that has one more question. But
Sure.
Adam, if you would like to enter your question in the chat box, and it's probably went to here. There's one question from Adam. What is the success rate for making other parties responsible for contaminating a property in the long past?
Oh, okay. So I think if I read this correctly, Adam, you're asking if people have historically contaminated a site, and then they've long since gone, what is the success rate for making them responsible for that contamination that they caused? Again, lawyer question. I'll give you my engineering perspective on that. Definitely a lawyer question. Basically, when you buy a site, you buy as is. So if you don't do your environmental due diligence before buying a site, you bought it, you own it. It's very hard once you've bought a site to then sue back somebody that's past contaminated it. And that becomes an issue for people, not just for the site you've bought. Some people say, well, I bought the site right next to the gas station, and I know it's the gas station that contaminated my site and then my neighbor's site. The way the law deals with this is if groundwater flows from the gas station through your site to the other neighbor's site, you get sued first, and then the gas station gets sued, because directly the groundwater going through your site, it's coming from your site. You're on the hook for that. So it really does become a buyer beware. The success rate once you own it is very slim. Hence the baseline study, hence why people doing their due diligence and banks do their due diligence most extensively, because once you buy it, you own it. It's again, you'd have to consult the environmental lawyer, but from what I've seen over the past 30 years, there's not a lot of success in going back to somebody else who's contaminated a property once you own it.
It looks like he has a follow-up question about legacy purchases where it was, purchased in the early 1960s, and there was not even that kind of, that kind of regulation surrounding contaminants. So you buy it, then you own it now, and then looking back, you discover it's been contaminated. My thought on that is, like, if it's been there for that long, you might struggle to find a party or be able to prove that somebody has contaminated in the past. But again, I think, like Charna was saying, I do think that is something that needs to be that it'd have to go to court, and there would be a legal precedent for that, and it's going to vary case by case and contaminant by contaminant, and who has the pockets to pay for this kind of thing. So that's going to be definitely something you want to talk to an environmental lawyer about, because they will have the most sort of up-to-date information about that. I'm not sure if you have any other, yeah.
Yeah, there are a lot of sites. Thanks, Gavin. There are a lot of sites where the stuff has been sitting there since the 60s. You got a lot of DNAPL sites, the TCEPC sites that are sitting there that were from old either dry cleaners or any machine shopping operations that use the PCTC as degreasers, a lot of metalworking. They have been sitting there since the 60s. And again, it sounds terrible, but it's buyer beware. Once you own it, if the neighbors did that and it came from their site, they did it in the 60s and then they walked around, you absolutely have the legal right to try and recourse to try and recoup that. What your success rate is going to be, again, consult with an environmental lawyer, but most of the time it's slim to none. A lot of the impacts that were done by 1960s companies, the companies don't exist anymore. And so you can then take on the new owners of the property. So even though they didn't cause the contamination, you're responsible for what comes off your site. MECP's, understanding from my point is that if it's on your site and it doesn't go off site, that's great. That's your problem. You own it, deal with it. If your contamination migrates off site, then that's where the ministry steps in. If you've got stuff that's moving off your site and impacts other people, that's where orders can be issued and such like that. And then it becomes that roller coaster of who you can recoup the money from. Because as Gavin explained, it's not always who the original person was that did this, but where are the deeper pockets to go and find money to recoup from that. And it is an ongoing concern. We encourage our clients always to, in these complex cases or where you may be an offending party, to consult with an environmental lawyer and to do your investigations as privileged and confidential until you have a better understanding of what sits on your site and where it may go. Yeah. All right, sorry, Angie, back to you.
No, that's all we've got for now. So I'll give everyone a few minutes of their day back. And thank you so much again, everyone, for attending, and to OECM for hosting us. And we wish you all a great day and hope to speak with you again soon.
Thank you, Angie,
Thanks.
Charna and Gavin. Thank you. Have a great day all.